All right, let's talk about the night sky. I mean, really talk about it. We're going to go way beyond just a random sprinkle of lights and see it for what it is, a dynamic, predictable system. And the best part? You can totally understand it for yourself. Let's get started.
So, what if I told you that the amazing show you see up there every night, the sun rising, the stars wheeling overhead, the moon changing its shape, is all part of a grand illusion? Today, we're going to be cosmic detectives, and we're going to uncover the simple, elegant truths behind it all.
Okay, so if we're going to be detectives, the first thing we need is a map. And to chart the cosmos, astronomers came up with a pretty brilliant tool.
It's called the celestial sphere. Now, this isn't a real thing you can go out and touch. Think of it more like a giant, imaginary globe, with the Earth sitting right in the middle. All the stars are kind of painted on the inside of that globe. It's a super useful way to map everything out, even though we know those stars are all at wildly different distances from us.
And this concept completely changes what we think a constellation is. You know, like Orion the Hunter, we think of it as a group of stars. But really, a constellation is just a specific patch of the sky. It's a defined territory on our celestial map. So how many of these patches are there? There are exactly 88 official constellations. And together, they cover the entire sky, with no gaps in between. It's kind of like looking at a world map, but instead of countries, you have constellations. And here's the first big illusion we're going to bust. Those patterns you see, they are created purely by our point of view here on Earth. Two stars that look like they're right next to each other in a constellation could actually be hundreds of light years apart in deep space. They just happen to line up perfectly from where we're standing.
Okay, let's move on to the most fundamental motion we see every single day. It's a puzzle that's so common, so constant, that we almost never stop to even ask the question. I mean, really think about it. Why does this happen every single day without fail? The entire sky seems to be on this giant invisible wheel, turning over our heads from east to west. What's actually causing this?
And the answer is so simple, but it's also profound. It's not them, it's us. The sky isn't actually moving like that. Our planet Earth is spinning on its axis from west to east. You know, it's like when you're on a merry-go-round and it feels like the whole world is spinning around you in the other direction. That's exactly what's happening every day.
All right, let's tackle the next big mystery, the seasons. Now, this is easily one of the biggest misconceptions in all of astronomy, but the real answer is just so much cooler than the myth.
So let's do a quick pop quiz, true or false. We have summer because the Earth is closer to the sun. It just makes sense, right? You get closer to a campfire, you feel warmer. But believe it or not, that is completely false.
And here's the one simple clue that just blows that whole idea apart. Think about it. If seasons were about distance, the whole Earth would have summer at the same time. But we know that when people are having a barbecue in July in the Northern Hemisphere, people in the Southern Hemisphere are bundled up for winter. That one fact proves it's not about distance.
So here's the real deal. The myth is distance. The reality is all about the tilt. Our planet is tilted on its axis by about 23.5 degrees. So in the summer, your half of the planet is tilted towards the sun. The sunlight hits us more directly, like a focused beam from a flashlight. In the winter, we're tilted away, so that same sunlight comes in at a shallow angle and spreads out. It's all about the angle, not the distance.
And to make things even cooler, that tilt isn't perfectly fixed. Earth actually wobbles on its axis, kind of like a spinning top that's starting to slow down. It's a super slow wobble. It takes 26,000 years to make one circle. This is called precession, and it means that our North Star Polaris won't be our North Star forever. In about 13,000 years, the bright star Vega will take its place.
Okay, let's bring our focus a little closer to home and talk about our constant companion in the sky, the moon, and its own set of beautiful illusions.
So, why does the moon have phases? A lot of people guess that it's the Earth's shadow covering it up, but that's not it. That's what causes a lunar eclipse. The real reason is much simpler. Just like Earth, one half of the moon is always lit up by the sun. That's its day side. The phases we see are just our changing perspective of that sunlit half as the moon makes its journey around us. And fun fact, we always see the same side of the moon because it spins on its axis in the exact same amount of time it takes to orbit the Earth.
So that leads to a great question. If there's a new moon and a full moon every month, why don't we get eclipses every month? Well, it's because the alignment has to be perfect. The moon's orbit around the Earth is slightly tilted, so for an eclipse to happen, two things have to be true at the same time. The phase has to be just right, new or full, and the moon has to be crossing Earth's orbital path at that exact moment. It's a pretty rare cosmic coincidence.
And for our last piece of the puzzle, we're going to dive into a mystery that stumps some of the most brilliant minds in history for centuries: the strange, looping motion of the planets.
See, planets usually drift steadily in one direction against the backdrop of stars. But every so often, they appear to slow down, stop, and actually move backward for a few weeks before continuing on their way. This strange backward dance is called apparent retrograde motion, and if you believe the Earth is the center of the universe, it's a real headache to try and explain.
Now, the ancient Greeks were incredibly smart. They figured that if the Earth was moving, orbiting the Sun, then the nearby stars should seem to shift back and forth against the more distant stars over the course of a year. This effect is called stellar parallax. So they went out, they looked for it, and they saw nothing. Not a single twitch.
This put them in a serious logical bind. Seeing no shift at all left them with only two possible conclusions they could draw. What do you think they were?
Okay, here were their two choices. Possibility 1. The Earth is stationary, it doesn't move, and the entire universe revolves around us. This fits perfectly with what they saw or didn't see. Or possibility 2. The Earth does move, but the stars are so mind-bogglingly, unbelievably far away that the shift is just too tiny for the naked eye to detect.
And which one did they choose? They chose possibility number 1. They rejected the correct model of our solar system not because they were illogical, but because their imaginations couldn't stretch that far. The sheer scale the universe would need to have for the stars to be that distant was just too vast for them to accept, so they concluded the Earth must be still.
And that really brings us to a final, powerful thought. The Greeks were brilliant, but they chose a smaller, more comfortable universe because they couldn't grasp the true, immense scale of reality. It really makes you wonder, doesn't it? What unseen truths might we be missing today, simply because they're hidden by the limits of our own perspective? Thanks for joining me.